Welcome to this explainer. Today we're jumping right into a pretty mind-blowing concept from the heroesmartacademy Godly Learner series. We're going to be exploring the perfect design behind the universe's movements. I mean, have you ever actually stopped to wonder why our physical world operates with such insane precision? Why things don't just, randomly float away or stop for literally no reason? Well, today we are digging into the absolute bedrock of classical physics, Newton's 3 laws of motion, and we'll see how the source material connects these physical laws to a much larger philosophical framework.
So, the whole foundation of this curriculum is built on the idea that motion, it's not chaotic at all. It's actually governed by a highly predictable rulebook. The text draws directly from 1 Corinthians, quoting, "Let all things be done decently and in order." It uses this scripture to mirror what we see out there in the physical universe, presenting physics not just as a bunch of random math, but as a really profound reflection of structure and reliability. All right, here is our roadmap for today's explainer. First, we'll look at the order of motion. Second, the first law covering the rules of inertia. Third, the second law focusing on force and acceleration. Fourth, the third law detailing action and reaction. And finally, we'll wrap things up by looking at true education and peace.
Let's start right off with Section 1, the order of motion and why physics matters every day.
It's so easy to just think of classical physics as abstract numbers on a whiteboard somewhere. But this order is literally at work all around us, all the time. It's exactly how engineers figure out car crashes and design those life-saving crumple zones. It helps athletes perform at their peak by allowing us to design the perfect sports gear. And it predicts exactly how your seatbelt is going to protect you if you suddenly have to slam on the brakes. Everywhere you look, understanding these reliable rules really reveals the incredible safety protocols built right into reality itself.
Moving right along to Section 2, the first law. This is all about the rules of inertia and the resistance to change.
Okay, so here is Newton's first law, which is famously known as the law of inertia. It simply states that an object at rest stays at rest, and an object in motion stays in motion until acted on by a force. Basically, stuff just wants to keep doing whatever it's already doing. Picture a soccer ball sitting in the grass. It is going to sit there perfectly still forever until the force of your foot kicks it into action. On the flip side, because space is a vacuum, a spacecraft will just keep coasting at thousands of miles an hour through the cosmos, purely because there is absolutely no outside force out there to stop it.
But wait a second. Let's think about a real-world scenario here on Earth. If an object in motion wants to stay in motion forever, why does a coasting bike eventually stop, even if you never touch the brakes? What's actually slowing you down when you stop pedaling? Well, the culprit is friction. It's this hidden, opposing force that is literally stealing your momentum. It acts as the unseen force rubbing against your bike tires on the pavement or slowing down that rolling soccer ball against the blades of grass. Without friction from the ground or resistance from the air around us, you would honestly just keep coasting forward forever. Now for Section 3, the second law, which covers force and acceleration. Think of it like pushing a swing.
And that brings us to the big one, the famous equation, F equals ma. Newton's second law shows us exactly how much force you need to actually change something's motion. Force equals mass times acceleration. Simply put, if you want a kid on a playground swing to go higher, meaning you are accelerating their mass, you have to push them with a whole lot more effort.
Mass is absolutely the ultimate multiplier here. Let's look at two baseball bats to compare. If you've got a really light bat, well, it has less mass. So even if you swing it super fast, it produces way less acceleration on the baseball when they connect. But grab a heavy bat, that greater mass means that swinging it at the exact same speed applies massively more force to the ball upon impact. That's what sends it flying way out into the outfield.
So, how does this actually apply to, say, an engineering marvel you probably sit in every single day? Let's test your knowledge. Based on what we just learned, how do airbags use Newton's laws to protect passengers during a crash?
Here's how it works. In a crash, your body is that object in motion that wants to desperately stay in motion, right? The airbag deploys in just milliseconds to safely absorb that force. It essentially acts as a cushion to change your acceleration. By slowing down your forward motion gradually over a fraction of a second, rather than you stopping instantly against a hard steering wheel, it expertly manages that F equals ma equation to drastically lower the total force hitting your body. It's brilliant.
All right, Section 4, the third law. This is the law of action and reaction, also known as the law of pairs.
Newton's third law tells us that for every action, there is an equal and opposite reaction. Essentially, forces always travel in pairs. If you walk right up to a solid brick wall and give it a hard push, you might not realize it, but that wall is actually pushing back against your hands with the exact same amount of force. It absolutely does not matter that the wall doesn't budge. The opposing force is perfectly matched to your push.
And this action-reaction combo, it's literally the secret to escaping Earth's gravity. Let's look at the steps for a rocket. Step 1, the rocket's engines fire, and millions of pounds of exhaust push straight down with unbelievable force. That's our action. Step 2, that extreme downward action generates an equal and opposite reaction, and the rocket is propelled upward into the sky.
You can actually test this one out yourself next time you're out on the water. If you stand on a small, unanchored boat and jump forward onto a dock, what happens? The boat shoots backward. The forward action of your body inherently causes the exact opposite reaction. The boat is pushed away behind you.
Finally, Section 5, True Education and Peace. Let's apply this philosophy.
Now, the heroesmartacademy series shifts gears here, transitioning from the physical rules of the universe to the rules for our own minds. They draw this really fascinating philosophical parallel. The source material argues that education without morality simply leads to bad choices and hurt. Like a person could fully understand the complexities of F equals ma, but without a moral compass, they could still use that knowledge to cause harm. So the curriculum emphasizes that education with morality is what actually brings true understanding and genuine safety to society. To back this up, the curriculum points straight to Romans 8:6-7, which promises peace of mind to everyone who keeps their mind spiritual. The idea presented here is that by aligning our minds with these spiritual truths, we can actually experience the exact same perfect, reliable order and deep peace that flawlessly governs things like gravity, the planets, and the stars.
So as we wrap up today's explainer, I really want to leave you with a thought-provoking question straight from the series. You know the physical laws of motion now, but are you intentionally choosing the path that brings peace to your own mind? It's a pretty profound intersection of science and spirituality to think about. Thanks so much for learning with me today, and I'll catch you on the next explainer.